Okay, we are recording the meeting from this minute. Uh, let's start. Good morning and good evening to all, and welcome to the Data-Driven Community virtual meeting. During the meeting, please use the chat for questions and discussions. Not only question, feel like this is a user group and not a lecture. So if you want to answer someone else's point of view, you are more than welcome. You are also welcome to use the reaction. I like it very much. It doesn't interfere with the course of the meeting. If you hear something that you love, like, or you just want to clap hands virtually, then feel free to do so. This is our first meeting for 2024 and a great opportunity to wish you all a happy and safe new year. My wishing to all is may you finish the year with more knowledge than you started it, and we will be here to help you to reach this goal. So who we are in a few words. We are all part of a data-driven community. We are managing two branches of activity, an annual conference called Future Data-Driven Summit, and a weekly meeting of the Cloud Data-Driven User Group, like today. My name is Ronen Arieli. I'm from Israel, working as a senior consultant in the field of data platform and architecture of enterprise level system. I'm co-admin of the data-driven community, and today I will be hosting the session. We also have Jen Joseph here with us. Jen is the founder of the data-driven community, and he will present the first technical lecture for 2024. So Jen, you are welcome to share your screen and take control. Please start with some words for the new year, a few sentences about the community, and present yourself.
Great. Thank you so much, Wonen, and it's always a pleasure to work with you. I would say Wonen is, even though I'm the founder, but I can consider Wonen as the primary person for this community because you have done a lot since you volunteered to contribute and work together to support our community. Thanks a lot, Wonen. And one more time, Happy New Year. And I'd like to say a special thanks to all attendees. And it's 2024. I wish you all the best. And yeah, let's continue meeting weekly as Wonen mentioned. We also launch yearly event like feature data driven. We have Psycho Saturday and
Just
keeping.
one word, you do not share your screen at this point.
Oh, perfect. I have it. I thought that I did. Thank you so much, Ronan. Okay, let me share my screen. I have screen. Okay. Are you able to see my screen now?
Not yet.
Wh- Which
Okay.
one?
Uh,
Which one you are
one.
seeing?
Yeah, I see the presentation, Cloud Data Driven, Jen Joseph.
Perfect. Thank you. Yeah. So I will. So therefore, I wish you the best and keep don't forget to share um, uh, this community with your peer because it's great sometimes to get together to learn from one another. By the way, I'm based out of New Jersey, originally from Haiti. You might feel the Creole or French accent. Yeah. And if you do have a questions like Wonen mentioned, feel free to drop it in the chat. And I'll do my best to walk you to uh, the main thing you might need to think when you want to leverage LLM, right? That doesn't mean you have to follow them. Those are this presentation is based on my experience and what I have learned from others as well. And I yeah, I'm a data engineer and currently working for Microsoft as a technical trainer, mainly focused on data and AI. Yeah, perfect. I'm a father for three handsome boys. Yeah, plus a stepdaughter. I think enough about me. And this is our agenda. Anytime when I'm presenting this presentation, they said it's always great to give an introductions into the generative AI, and therefore we can understand how it works before you deep dive into prompt engineering. So that's the reason why I have a quick intro, because I have it based on comments, and I'm gonna go over some advanced prompt engineering. Speaking of generative AI, we can think of artificial intelligence, right? So what I mean by it is not something new. Artificial intelligence been there since 2019, and the science behind artificial intelligence is to allow the machine to mimic human. What I mean by see, think, right? And also performing tasks that we as human normally do, because as human we require breaks, vacation. The machine doesn't require that. And the goal, the intent behind artificial intelligence is to make our life become more efficient. However, and during that time, uh, 1956, we didn't have enough compute and we didn't have enough storage and data. So artificial intelligence couldn't be a big deal. In 29, in 1997, we came up with machine learning to overcome the limitation of artificial neural network, right? And learning is, is a subset of artificial intelligence, and the science behind machine learning is to allow the machine to learn on its own without being explicitly programming. But machine learning come with a limitation. If we have to analyze the neural network, right, we cannot go beyond 3 layers. So therefore, if we have to perform unstructured or complex operation, machine learning may not suitable for that. So in 2017, we come up with deep learning to overcome the limitation of machine learning. And the deep learning and machine learning use kind of the same neural network architecture, except that deep learning can go beyond 3 layers because we can have more, right? And the intent behind deep learning is to mimic how we think, our brain. So now, but here's the thing. From 1956 all the way to 2017, it was more about coding and computations, right? Coding comes first. So you need to know how to code and you need to understand statistical, uh, mathematics, you need to understand machine learning well. Those concepts, you require that. And remember what I said early, the intent behind artificial intelligence is to make our life efficient. If if the target is for us, not all of us could have leverage machine learning from this period, because we first of all have to know how to code. Even though if we do know how to code, we need to understand the functionalities, the steps involved. What is preprocessing mean? What is finding the right model that fit your need? What does that mean? And how to split the training data set. You need to understand that, right? But guess what? How can we make artificial intelligence available to everyone, even though if they understand the architecture uh, and the process behind the scene? How can we leverage compute and we remove code? right? This is where the generative AI comes in because the generative AI allow you to leverage natural language processing to communicate with
Can
LLM. What? Hello?
can you change? Yeah, can you download a bit your camera because the camera is like this.
Yeah, the camera is a little bit far from me. Is it
Okay,
good
it's
now?
not.
Is it good now?
Yeah, yes, yes, it's great.
Okay, perfect. Thank you. So now, and in order to eliminate coding, we need to come up with a strategy. That strategy it couldn't be something else beside language. So how can we allow human to talk or type something? The only thing that require is computation. So this is where the generative comes in, where you leverage natural language processing to communicate with foundation model. So in our case, I will mainly focus on ChatGPT. So therefore, how does ChatGPT works, right? Consider if you have a questions, right? Or you have an idea and you need to look for more informations in a conversational manner. You can't use uh, the basic Ben or Google. You can do that because those are based on keywords, right? So now, in order to communicate just using computations, it will require, as I said, natural language processing. Consider if I don't know Power BI and I need to know exactly what is Power BI. So this can be considered as an user input. How does it work? When you submit that, there will be a pre-processing occur. So what I mean by, and before the input is fed into the encoder of a large language model, there are several pre-processing steps that occur. And these steps may vary depending on the type and the architecture of LLMs. In the context of machine learning, the first thing you have to think is padding, right? Padding is usually performed before tokenizations. And padding is used to ensure that all sequences in a list have the same length. And this is important because machine learning model require input data to have a fixed size. And padding is achieved by adding zero to the end of shorter sequence. So once the padding is completed, then the tokenization take place. And tokenization is the process of splitting the input and output text into smaller units. And those units is what we call tokens, right? And tokens are the basic units. We can think of them as text code for LLM AI model to process using generate language. And tokens can be as well character, it can be subword, it can be a symbol, depending on the type and the size of the model. But guess what? You might see the splitting done. We have a B, right? Um, uh, the wall of B in the string is to indicate that the string is a byte string, which means that it is a sequence of byte rather than character. So once the splitting is done during the tokenizations, guess what happened? This is where the transformer take place, right? And the transformer architecture consists of two main components, as you can see here. We have encoder and decoder. The encoder takes the input, okay, after the tokenization is done and convert it into a sequence of vector called embedding. that capture the meaning and context of each word. The encoder takes the embedding and generate the output text, one word at a time. So therefore, you can consider the transformer as a token predictions, right? Or you can consider LLM as a vector processing tools, right? So things you need to understand both the encoder and the decoder, right? Use positional encoding, attention and self-attention mechanisms to process the text. Positional encoding is a way of adding information about relative position of each word in the sequence to the embedding. Attention is a way of focusing on the most relevant parts of the input or output text of each word generation. Self-attention is a special case of attention where the input and output are the same sequence, right? Positional encoding, attention, and self-attentions are essential for the transformer architecture to learn the complex pattern and dependencies in natural language. They enable ChatGPT to produce coherent and fluent text across different domain and tasks. But guess what happened? If you pay close attention right here, the user input is what bring we call what prompt. And this is what generated, you know, this is where prompt engineering comes in. So therefore, what is prompt engineering, right? Prompt engineering is the process of creating effective prompt that enable AI model to generate response based on given input. A prompt can be as simple as a few words or a complex of an entire paragraph. And it serves as the starting point for an AI model to generate a response. Prompt engineering is essential, uh, is especially useful for working with large language model, what we call LLMs, and that can perform different or a variety of natural language processing tasks, such as summarizations, as you can see, entity recognitions, topic classification, sentimental analysis, and it can do paragraph sentence generation. You can perform all of that. But here's the thing, and prompt engineering may sound a little bit or relatively new and evolving fields. However, it requires okay creativity, I would say experimentation and persistence. Uh, why am I saying this? Because you're leveraging natural language processing. You may ignore context, and context matter. As I mentioned, the transformer is all about attention. So, and things you need to understand in order for you to better communicate with LLM, you need to understand the different strategy that you can leverage. For example, we can there are different type of prompt we can think of, such as direct prompting, prompting with example, chain of thought, prompting, and each with their own advantage and challenging. And prompt engineering also involve iterating, okay, and refining the prompt to improve the quality and accuracy of the model response. So you can see that here, this is the decoder. We already explained this, right? Very simple from previous slide. NLP, this stands for natural language processing, right? Which give LLM the ability or which provide the ability of uh, to which provide LLM the ability to understand and generate natural language, right? Such as speech, text. So NLP use method from computer science, linguistics, and data science to analyze and manipulate large amount of natural language data. However, NLP leverage two other languages. It leverage the first one, what we call uh, NLU. NLU is stand for Natural Language Understanding, right? Which is a subset of NLP that focus on interpreting the meaning and intent behind natural language sentence. NLU use syntactic and semantic analysis to extract relevant information and establish relationship between words and phrases. And once NLU detect the intent, the response will not generate it by NLU. This is where the NLG comes in. And NLG stands for Natural Language Generation, which is another subset of NLP that focus on interpreting the meaning and sorry, that focus on involving creating natural language sentence and text based on specific prompt or data. NLG use algorithmic and rule to produce coherent and human like language response. So if so now you can tell that prompt engineering is not uneasy as it sounds, right? It's not easy as it sounds. It requires a lot of skills and practice to achieve effective result. And prompt engineering, I would consider this as an art and a science, and it's involved finding the right balance between clarity, specificity, and creativity. Prompt engineering also is an ongoing process as new model and tasks emerge and require new prompt, right? And lastly, I can summarize that prompt engineering is a bit challenging but rewarding field, and it can unlock the potential with prompt engineering. Il- eh, you can leverage this to unlock the potential of AI model to perform amazing natural language processing tasks. Therefore, there are some rules you might need to follow. For example, consider if I have a files and uh, before I go to that example, when you're creating your prompt, you might need to consider context and primer. And remember how I define prompt engineering. I define this as the scale of designing effective prompt that guide the model to generate desired output from given input, right? So therefore, you might need to consider a couple component to increase the level of accuracy for the generative response, what we call completions, right? First thing we might need to think of is context and primer. So this is the background information or data that helps the model understand the task and the domain, right? It can be text, an image, a table, or a combination of these, right? For example, consider if the task was to generate a summary of a new article, right? The context and the primer can be the title and the first paragraph of the articles. So you and remember instructions matter, right? So instructions is um, this is the comment or question that tell the model what to do or what to answer. It should be clear, concise, and specific. Consider, for example, if the task was to generate a summary of a new article, the instruction would be write a summary of the article in 3 sentences. And sometimes our goal could be big, huge. It's going to be hard to uh, send the entire goal into one paragraph because you have to take in consideration, and sometimes loss may occur. So anything in between, the model can get lost. So therefore, with that, it always good, for example, to um, uh, to measure in, what would I say? It's you can think of, the goal is that, is it has to be expected, the kind of result you expected, you have to be able to measure it, and you need to understand if this is achievable, right? Unless if you're doing things, you're not sure exactly what you're looking for. So what I mean by that is that, consider if the task is to generate a summary of a new article, the specific goal can be, the summary should capture the main point and fact of the article without any personal information or bias, right? And then the size of your goal matters. Sometimes it's always best, to break down your goal in, the instructions as well into, different, uh, into smaller, goal, instead of sending the entire goal to the LLM. And then there is also, the length and the output. And remember, the Windows context matter. So if you don't take this in consideration, accuracy or expectation can be unexpected, right? So uh, when it comes to length and output indicator, right? So this is, the indication of how long or short, the output should be and how it should be formatted or presented. It can be a word limit, it can be a sentence limit, right? It can be a bullet point, it can be a code block, or it can be a combinations of these, right? For example, here, as you can see, if the task is to write an essay on a topic, the length and the output indicator can be the essay should be between 500 and 700 word long, and it should have an introductions, three-body paragraph, and a conclusions. And sometimes you might need to provide examples, like, for examples, this is the method of using specific and varied examples to illustrate, the task and the output. So it can help the model learn from existing data and generate more accurate and relevant results. More will come later during the demo. And we also have tones, right? Tones, this is the attitude or emotion that the prompt convey to the model and the user. It can be formal, informal, friendly, serious, or humor. And we also have, demography, right? This is the characteristic or feature of the model and the user that can affect the task and the output. It can be age, right? For demography, it can be gender, culture, language, education, and then we might need to also think of the target audience, right? This is the group or the category of people who will use or benefit from the task and the output. It can be student, teacher, researcher, customer. If I have to go for this example, if the task is to write an essay on a topic, target audience can be professor who will grade it. Like, this is a simple example. Consider if I have a files in, my data lake, and I want to load that files, and this is a request from business, and I have no idea what is, Synapse dedicated SQL pool is. I have no idea what is SQL is about. I can leverage the power of, LLM or ChatGPT to generate that. So the context would be you are a data engineer task with prompting, with importing data from Azure Data Lake into a SQL Server, into, sorry, Synapse dedicated SQL pool. The instructions would be write a SQL script using copy command to import a CSV files. And that CSV files has header, and then it is the source is Azure Data Lake, and destination is a dedicated SQL pool. So the input data could be the CSV file has colon, okay, for product ID, okay, all the way to selling price. This is the goal. The goal should be specific and measurable and achievable. As I explained, you have to create a staging table name sales temp with all colon as VACA 255. The reason why we say VACA 255 is because during the loading process, we do not want conversion to fail. And another table name cells that's going to be the production name with the current schema definition. And then for each colon, okay, use manage identity to authenticate and specify file type instead of format, because if it's on premises, we may use format. On cloud, it, it has to be file type, and then use into close and mention the field name, like we give it an example. So this is where we're breaking down the example into a smaller task. First, create the staging table, okay, and then create the sales table with the current schema, and then next, okay, write your TSQL script to import the data. So you give the model enough information, it knows what to do, and the output indicated should be a TSQL script that successfully import the file into Synapse dedicated SQL pool. This is just an example. If we have to go to a demo, let me show you this. Is that let me see, do I have that slide or did I hide it? So it seems like I had it, but let me go back here. So I'm gonna bring this back here, okay? And I'm gonna go to my, give me a second, I already clean this up, okay? This is, for example, I have this notebook, okay? Before I go too deep into,
Please remove a bit.
can, can you see my screen? Is that what you
Yeah, but
said?
it's small. Can you please enlarge the text?
Oh, how can I quickly do that?
Control and with the scroller, scroll up to make it larger.
Yeah, I did. I did.
No, it didn't work.
Yeah. I'm not sure how can I quick. Is there anyone me on the call know how to quickly get this done?
You can do it in the setting, but it will take time. So
Okay,
just
perfect.
continue.
Perfect. So these are the parameter. We will not spend time here. Uh, this is, for example, let me go back here. Is this the one I wanna demo first? Okay, give me one second. Perfect. So you can ignore this. This is the connection to my Azure OpenAI. I am creating a functions, and these functions just to connect to Azure OpenAI. You can instead of keep executing this piece of code, okay, I just have a functions to execute it for me. That's what I'm doing here, right? And then when as I explained, when it comes to prompt engineering, you might hear something say zero shot. Zero shot is when you provide no examples. So what advantage do you get? It does not require any additional training data or label. So that can save you time and resource, right? It can also enable the model to perform a wide range of tasks, such as classification, sentimental analysis, and question answering, event text, and more. It can also leverage the general knowledge and language scale of the model to generate response. But the downside of zero shot example is that the quality and accuracy of the output may vary depending on the prompt. So the model and the task, just keep that in mind. Not only that, it may contain factual error or inconsistency that are not easy to detect or correct. And then it can also be influenced by the bias or preferences of the model, or even on the data it has been trained. So the output may not be in line with your expectation or goal. So zero shot. Those are the example. Consider if this is my prompt. What is Power BI? If I execute this prompt, okay, and I execute my functions, this is the response, right? The response rely on what on the general intelligence of the LLM. And sometimes you might want to be more specific. And the way to do that is to provide examples. If you want to provide a single example, this is what we call one-shot example. So one-shot example allow you to overcome the limitation and challenging we were facing uh, when we're using, for example, one shot, right? And or even few shot prompting. So providing the model with a single example of the input and output pair that can help the model to return a better information and perform a better task. The advantage you get of that, it can improve the performance of the model by providing it will leverage your example to generate a response, okay, that suits your need. And then also it can help the model to follow the format and style, even tone of the example. There's a pro and cons there too, right? Which can improve consistency and accuracy. And when it comes to one shot, it can help the model to handle more complex and specific cases, that may not be covered by zero prompting. The downside of this, just to keep in mind, the quality and accuracy of the output may depend on the quality and relevance of the example provided. So if you have to provide an example, you need to make sure you provide those example as expected, because the output may be too similar. Okay, the response you can get can be close to exact to the example that you provided. So just keep that in mind. And when you're providing example, now the output may not capture all the importance or specific details of the input, so which can reduce completeness or information. Just keep that in mind. Here is just a single example of one short prompting. You can see now the model base the difference between here is here I just said what is Power BI. So the model just guess. So here I said generate a paragraph of 100 or less that summarize the benefit of Power BI, a business intelligence tool by Microsoft, and the model was able to generate the data accordingly to that input. And sometimes one shot may not be suitable. You might need to provide more than one shot. This is what we call few shot. And few shot is a technique that provide the model with multiple example, right? And then the advantage you get is that it can fine tune the performance of the model, right? And then it can also help the model handle more complex tasks or specific cases. Moreover, it can help the model generalize better to unseen or novel input by reducing overfitting or underfitting. The downside of this is kind of the same thing as one shot pump, except that, and when it comes to few shot, it can be more costly than zero or one shot, because the more simple you give, the more the model has to learn. So therefore, it will require more compute and scale. Just keep that in mind. And you have to take in consideration the max token as well, because every Windows context have a limitation, right? And also is that, and the quality and accuracy of the output may depend on the quality and the diversity of the example that we provide. If you see here, I said write a short article about the benefit of meditation, and I'm providing these two examples. You can clearly see the response is kind of close to what I provided, but with different tones and style. And then if you go, you read the message, you will see it's kind of close, but you might need to take in, you might need, for example, to take this in consideration. So anytime when you're doing summarizations, when you're doing an name entity recognitions, one few shot or one shot might be useful. But guess what happened? There will be cases if you're doing calculation that require the model to think. Few shot or one shot prompting may not be suitable. This is where you might need to think of what we call chain of thoughts. Chain of thoughts involve providing intermediate reasoning steps that lead the model, okay, to the final output. It is more suitable for tasks that involve like arithmetic, common sense, or symbolic reasoning. And for example, here, I tell the model to do a calculations. I said, calculate the value of 781 times 55, then subtract 122 from the result, write the same answer in one sentence. So if you take a look, this is our expectation, 42,832. The model come up with this result. It didn't give me the right answer. So what I did here, I rewrite the same thing, is just the same thing. I just give it a hint here. The hint here, because of time, I don't want to read the entire thing. I just give it instructions on how I would proceed this. Okay, not the exact number, as long as I can learn from it. And alternatively, I tell it I can use a calculator or tool like search word to get the answer, right? When I execute this, it's give me the expected result set, as you can see. So within the example we just saw on my slide deck, we have the file, right? This is the file we want to load. This is the prompt, right? That's the prompt we provide. Okay, this is the prompt we provided. We tell it to first create two schema, name STG. Because of time, I'm not gonna read anything. You can see everything. You can see that I mentioned comment here. This is kind of input parameter, and I also mentioned schema. If I can see it here, and you can see I have comment here and I have schema, so it knows where to get that information. When I execute, when I pass this to the message and use that, and I'm defining a script to create some file. And when this is the functions, I alter the functions to add these uh, functions to create the file. This is it. When I execute this, okay, and before I execute it, I want my chat GPT to be concise, okay, because I do not want chat GPT to be intelligent, because if it's intelligent, it can add copy code comment. So this is where I'm low. I put the temperature to be 0, right? And I increase my max token, right, to 1,000, because I need more response. If this one is low, there will be truncation occur during the completion times. If this one is high, it may impact cost. And not only cost can impact, you have to respect the window size and context may involve as well. So accuracy can impact as well. So I mean, so what I do, I just want this to be 1000 and I execute this, it goes and create and generate the entire script for me. But I came from development and production. Having everything into one file is not suitable if we have to maintain CI/CD, right? So what I did here is that I want ChatGPT to go and create each object separately, including the loading process. So what I'm doing here, I'm loading information that will allow me to access Azure OpenAI, and this is a function that I just defined. And when I execute that functions that I can connect to my database. So I want ChatGPT to create that those script and create a database, create those objects and load that data. So what I'm doing here, I have a JSON file. The JSON file using a system role. The system role is what will guide the assistant to perform the completions. So I am assigning a role and tell it what to do. I will share this with you. You can read it. And then I'm defining each prompt separately. Okay, so this is the part that I will be using. Okay, so this is the system role, and I'm telling it to create, to generate a script to create a SQL Server database, name it Azure OpenAI, create a schema STG, create a schema PRD, and also generate a script to create a staging table and the final table, and then provide a script to book load. Okay, and I'm telling it just provide the book load TSQL script without creating table statement. Okay, so now here, what I'm doing here, if I go back here, I create a functions to control the behavior of each files. Okay, so I'm using the index to create each file. Based on that index, I'm generating the name. Okay, if I execute this one here, you can see here we don't have any files here. I am creating the functions that I just explained earlier. That functions is what will execute. For the demo purpose, I comment this out, as you can see, right? So now, if I load this to the memory and I execute this, as soon as I execute this, you will see there will be files created. And those files, I have my database created. I have my table. I have, for example, my schema. I have the order schema. I have the stage table, and I have the book load. So therefore, I can have LLM to perform the entire task using, for example, uh, uh, infrastructure as prompt instead of code. So I can, for example, have it this way and generate this. I can keep on adding more logic and have it there. But things you might need to keep in mind if if you're using a different version of LLM, your prompt might need to be fine-tuned or updated. So there are some other things we might need to think of. If we think of advanced, we have only 1 hour and I have to leave in 5 minutes. We have few short, chain of thought, self-consistency. I won't have time to define all of them, but sometimes we might need to tell the model to ignore the knowledge it has and focus on on your own private data. So this is where RAG might comes in, right? And we have, and as you know, self attention, and it's all the transformer require. You might need to think of retriever augmented generation, and the way it works, if you have your document, you can leverage them, chunk them, and then using Azure Search and create leverage Azure OpenAI to create it to embed it. Okay, and then with search, guess what happened? If someone want to leverage, for example, LLM, they can still connect to Azure uh, OpenAI, and they can query that data, but both input will be embedded. And then consider, for example, if they need access directly, they can do that. So if you have to go to the portal to perform same actions, I think I must have this open. If you click me on the chat completion, you come back here, you can go and add your data. So when you add your data, there is a feature that turn off the intelligence of your model. So therefore, you can communicate with your model using your internal knowledge. However, if you disable that feature, it will be a shared knowledge. Your internal knowledge is the LLM knowledge. So, right. And to be honest with you, I would love to spend more time. And if you have any questions, I know I can only stay for 3 to 4 minutes. I have to join another meeting at 1. Hopefully you learn something out of this. Or otherwise, Happy New Year and thank you for joining my session. Back to you, Wonan. Thank you so much, Wonan. And thanks everyone for joining. Wonan, I can't hear you, Wonan.
Oh, okay. Now you can hear me. I was muted. First of all, I said thanks a lot for the session. It was a great session. Thanks everyone that joined us. There was some discussion during the session in the chat, but there is no specific question. There are a lot of thanks, and it was great session. We have about 1 more minute if someone has like last minute question. We do have someone that raised his hand. Maria, I will open the microphone for everyone. So 1 second. Let me go to the setting. You can open your camera all. I will take a screenshot of everyone in the meeting if you want. Let me just allow everyone to open camera, allow mic, allow camera, save. Okay, you are more than welcome, everyone, to open your camera. And Maria, you can ask some question if you want to speak. Oh, okay. She didn't meant to raise her hand. So thanks a lot again, Jen. I understand that you need to go. Thanks everyone for joining us, and welcome to the community for the new members here. We are meeting almost every week at the same time. Follow us. We are recording this session, and we will inform you when it's ready. You can follow us on social media. Thanks a lot.
Thank you. Bye-bye.
Bye bye all. Have a great day. Happy New Year.